A very warm welcome to all of you joining us today for tutorial 1 of the International Conference on Artificial Intelligence and Data Sciences 2025, organized by the Sri Lanka Association for the Advancement of Science in a collaboration with the Southeastern University of Sri Lanka. Today's tutorial focuses on AI ML driven VLSI system design for next generation wireless communication technologies, an area at the forefront of innovation that bridges artificial intelligence, machine learning, and advanced chip design for wireless communication systems. We are honored to have with us our distinguished panel of experts, Dr. Sabyasachi Bhattacharya, Dr. Swegita Devi, Dr. Shweta Ansa, and Dr. Ganapriya Singh, who will share their insights and research expertise on this fascinating topic. To officially commence today's tutorial, I would now like to warmly invite the tutorial session coordinators. Ms. Sana Slati, Senior Lecturer, Department of Computer Science and Engineering, Southeastern University of Sri Lanka, and Dr. Pashan Madhuranga, Senior Lecturer, Department of Electrical and Electronic Engineering, University of Sri Jayawardenepura. We would now like to invite Dr. Pashan Madhuranga to introduce our distinguished speakers for today's tutorial session. Over to you, Dr. Pashan.
Okay, thank you, Atif. I hope I am audible, right? Okay, so I will formally introduce our four speakers today. And once again, thank you very much for accepting our invitation on this occasion. So first, I will introduce Dr. Sabyasachi. Dr. Sabyasachi Bhattacharya is an assistant professor in the Department of Electronics and Telecommunication Engineering, Barak Valley Engineering College, Government of Assam, India. Currently deputed to Residential Girls Polytechnic, Golaghat. He earned his BTech degree from Assam Don Bosco University in 2013, MTech from Guwahati University in 2016, and PhD from IIIT Guwahati in 2023. He is also pursuing postdoctoral research in physical layer cybersecurity for satellite networks in collaboration with the University of South Florida and Guwahati University. His research interests include 5G communication, DPLL-based systems, and wireless security. Dr. Bhattacharya has several SCI and Scopus Index publications and also serves as a reviewer and committee member for IEEE journals and international conferences. He has also delivered invited talks and at prominent IEEE events worldwide. So let me introduce our second speaker today, Dr. Swagata Devi. Dr. Swagata Devi is presently working as an assistant professor at Assam Downtown University, Guwahati. She holds PhD from the Department of Electronics and Communication Engineering, NIT Silchar. She has previously served as contractual faculty at NIT Silchar as well as full-time regular faculty at BVRIT Narasapur. Her research areas focuses on analog VLSI circuit design and optimization. Her doctoral thesis explored swarm-based artificial neural networks for detecting neural spike in epilepsy. Her present research also focuses on highly on AI/ML-based VLSI design advances towards next generation wireless communication systems. Our third resource person here today is Dr. Shweta Shah. Dr. Shweta is an associate professor in the Department of Electronics Engineering at Sardar Vallabhbhai National Institute of Technology SVNIT Surat, where she has served since 2004. She holds a bachelor degree, Mass MTech, and PhD in wireless communication. She has been a key contributor to NAVIC research since 2015. She has guided over 50 plus UG projects, 10 plus PG theses, and 6 PhD scholars. She has led ISRO and DST funded project worth 1.25 million Indian rupees and mentored several TEQIP initiatives. With 30 plus journal papers and 20 plus conference papers, 6 book chapters, and 3 patents, Dr. Shah is active in IEEE, IETE, ISTE, ACM, and ION. She also served as Associate Dean Student Welfare at SVNIT. And our final speaker today is Dr. Ganapriya Singh. She is currently working as an assistant professor grade 1 in the Department of Electronics and Communication Engineering, National Institute of Technology NIT Kurukshetra since 2022. Prior to this, she was working as an assistant professor in the Department of Electronics Engineering at NIT. Since 2013, she has received her PhD degree in signal processing from IIT Delhi. During her research at IIT, she was working on project with STM Microelectronics, California, USA. Her research work done at IIT was also showcased at CSC USA. This is the largest consumer electronics show. She is an inventor on 5 granted US patent and 1 European patent. She is an investigator in the project funded by Ministry of Electronics and Information Technology and Development and Science and Technology Government of India. She has authored in high impact fact ACI journals. Her current research interests include context awareness, image processing, and signal processing for IoT. Okay, I cordially invite Dr. Sabya Sashi to take over the session. Thank you very much.
Yeah. Good evening to one and all in India and Sri Lanka, and to hello to all esteemed participants and members of this pre-conference tutorial session of ICAIDS 2025. I hope I'm audible, Dr. Pasan. Hope I'm audible.
Yes, you're audible. Yeah.
Okay, thank you. So firstly, at the onset, I, on behalf of all my co-collaborators on this tutorial, Dr. Swagata Devi, Sam Downtown University, Dr. Shweta N. Shah ma'am, SVNIT Surat, Dr. Ghanapriya Singh, NIT Kurukshetra. We would like to cordially thank you for inviting us for this conference. Special thanks goes to Dr. Latif Madam and also Dr. Pasan Madhuranga sir for giving us this cordial invitation and the opportunity to showcase some of the recent advances in AI/ML based wireless communications and its interconnections with the VLSI designs for the next generation of communication. So it will be basically the entire talk today will basically be focused on 3 parts. The initial part shall be taken up by me, where I'll be discussing the recent advances related to next gen wireless communications, where how the AI and ML has come into the picture. That would do the context setting for this lecture, which will be in the next part taken up by Dr. Swagata Devi ma'am, who would be dealing with the AI/ML based advances, VLSI based approaches, and its application in the wireless communication domain. And the third part of this tutorial talk will be delivered by Dr. Shweta and Shah ma'am, where she would be dealing on intelligent reflecting surfaces and some of the key applications in next gen wireless communications. So I would now request my co-collaborator, Dr. Devi ma'am, Dr. Devi ma'am, to if you could please share the screen. are this just a gentle query? Are the slides visible at your end? Because it's not visible at mine actually, at my side.
Okay, it's not yet visible.
No, ma'am, it's not yet visible.
Okay, okay, let me try again.
Yeah.
Is it coming now?
Yeah, it's visible, ma'am. Thank you. Thank you so much. Thank you.
Okay.
Okay, thank you. Okay, so let us quickly start off with the deliberation. So a big thank you to the Sri Lankan Association for Advancement of Science Eastern Chapter in collaboration with SCUSL and its associated IEEE units, the WIE unit and the student group. So the tutorial presentation, as I have already mentioned, is about the AIML driven VLSI system design for the next generation wireless communication technologies. On the screen are all the presenters. So I will be starting off with my deliberation. Ma'am, next slide, please. So my part would be basically fundamental in the aspect that I'll be discussing what are the advances related to the next generation wireless communications in general, without specific emphasis on the VLSI aspects. However, I'll be touching upon where exactly VLSI designs would play a key role in the coming era of communications and computing. So these are some of the contents, the plan of talk, where we shall be discussing on the different 5G and 6G technologies, the advent of IoT, quantum communications, AIML approach in cellular networks, and also certain other sustainable aspects where VLSI and such upcoming technologies would play a key role in future communications. Next slide, ma'am. So our objective here is basically to understand that the next generation of communications will lead to evolution in the cellular networks, and we need to be familiar with the different 5G and 6G technologies, and we also have to slowly look forward to beyond 6G as well, although the deployment of 6G is targeted to be only in 2030, but already quite a number of research has already started worldwide, which is targeting the 7th generation of wireless communications as well. The importance of IoT in cellular technologies that has to be understood, and also other technologies in cellular networks. And we need to also take care of the fact that with the increase in the number of devices, and the security aspects related to our cellular networks or wireless networks would be a key challenge. Madam, next slide. So as we might know, how actually to introduce the thing to you or to set the context. So our society has now become a society which where the mobile data traffic has gradually increased and is ever increasing, and the projected increase in the traffic, which is in terms of exabytes per month, is showcased here, which is from a cited reference basically, and it is showing an exponential rise, a steep rise in the amount of traffic that is basically connected, or that is basically associated to our devices, specifically the mobile data. So so basically what we can understand is that there are some lifestyle and societal changes where we are using apps for almost every aspect of our life, starting from very basic day-to-day needs till the high-end like the quality or the aesthetic needs. And therein comes the necessity of a high-quality communication system, where we are already talking about holographic society, where we will have virtual communications with physical presence through the augmented world or the virtual world basically. And there is a necessity for the ma'am, previous slide please. There is a necessity for the connectivity for all things actually. So basically it is now not IoT, that is the Internet of Things, but rather it is IoE, that is Internet of Everything. That is what is being targeted through 6G. And we are focusing on time sensitive and time engineered applications, where basically we are trying to utilize our channel's efficiency to the every last microsecond or last nanoseconds of our communication payload basically. So in that comes very time sensitive requirement which needs high speed networks, which need high speed devices, and therein obviously the circuit design aspect or the chip level design aspect will play a very major role. And for connectivity aspects also, the design and the system design aspects will play a key role. So this is just the context of our talk today. So ma'am, next slide. So this is how this is known to I guess the a larger context or a larger number of this audience of the conference or the tutorial. So this is how our data speeds have evolved from 1G to the 5G communication, where we dealt with only analog signals in 1G communications, which led to with 2G it became a digital cellular network leading to around 64 kbps of voice as well as data transmission, which where would project about voice communications and other wireless. It became a totally commercial application with speed over a very short period of yeah, so yeah, just to make sure that the network connectivity is stable, I save on the bandwidth. I'll just pause my video. Yeah, so so this is basically how the cellular networks have evolved. Cellular networks have evolved over the recent phase, right from the 1980s up to the 2020s or 2000, and we are projecting even higher speeds and higher amount of applications where we are expecting an HD movie to be downloaded over seconds basically. So this is about the evolution. Ma'am, next slide. Swagatam, next slide. So these are the comparisons when we consider about the 5G and the 6G. So if we consider about the data rate, then 5G would 5G was targeting around 0.1 Gbps to 20 Gbps, whereas in 6G we are already targeting to go to 1 Tbps of speed, wherein the reliability in 5G was around 10 power minus 5, wherein we are trying to reach almost 1 bit error in 10 power 9 bits basically. Whereas the round trip latency, when I speak about the latency where I mentioned here is basically the round trip latency was projected to be less than 5 milliseconds basically, and 5 milliseconds, but in 5G, whereas in 6G it is considered to be less than hundreds of nanoseconds. So there is a between 5G and 6G, as you can understand, there is a time scale shift from a micro scale level to a nanoscale level, to a high amount of micro scale level to a nanoscale level, and essentially at the parallel advent, the hardware structures or the VLSI based structures also need to change. Localization precision, if we consider, then we are having the localization of less than 10 centimeter in both the dimensions, whereas in 5G, whereas 6G targets it less than 1 centimeter, obviously considering nanoscale structures coming in big time, and that too with the advent of technologies in context of quantum and other applications. Now, madam, next slide. So these are some of the 6G driving applications, 6G trends, and 6G enabling technologies. So you, on the top, you can see that now we are talking about the multisensory XR applications, where we are talking about basically the internet of everything, where almost all the components at your home or the smart home would be connected to each other. We are talking about robotics and autonomous systems, which are hugely connected. Like every component would be connected to each other, and the autonomous systems or the expert systems, which were earlier limited only to specific applications, would now come down to the mass level or the mass scale level applications. Whereas in wireless brain-computer interactions, earlier the brain-computer interactions were limited only to applications related, which were related to synthesis or analysis, whereas now it would be focusing on full-fledged applications, real-time applications related to surgery, where a telerobotics, where a telerobotics sort of a situation could be imagined. The surgery would be from one remote place across countries. The surgery might be taking place at another different country. So as we are all aware that one such surgery has already been test tried and successfully tested in Japan. With we are having we are having a number of other applications also. Those applications are related to the financial sectors, where the ledger technologies are also changing with blockchain coming into the picture, and those can only be realized when the IMT standards are raised. The bar of those IMT standards are raised from the 5G till the 6G till the 6G level standards, or the specifications in terms of the speed, the reliability, and all other parameters is raised. The driving trends is basically it is about having more bits, but at the same time having spectrum reliability. We are also talking about the spectral efficiency and more amount of energy efficiency with the new technologies coming in. The NOMA technology, non-orthogonal multiple access, has already been modified across number of has faced a number of modifications as the 6G research is going on presently. We are talking about cells as low as picocells. We are talking about self-organizing networks or sustaining networks, where a network will self-understand or self-organize itself based on the different real-time network situations, where the network can not only estimate at what is the position of his what is the position or quality of the signal that that it is dealing with, but it can also change or self-organize itself and manage its resources so that the network performance can improve. We are talking about localization. We are talking about in terms of satellite communication. Satellite communication is revolving around now from a MEO or a GEO based satellite. It is now coming down to mass scale level applications, with LEO satellites gaining the popularity, and those would definitely require hardware changes of massive scale. And the end of the smartphone era would come in, and we would now look into newer technologies in mobile phones with the upcoming 6G standards. That is basically we should say that the smartphones would now become even more smarter actually. These are the enabling technologies coming in. We are having the above 6 gigahertz, terahertz communication is already in the picture. Large intelligent surfaces, which one of my co-collaborators, Dr. Shah, will be touching at the end of, towards the later half of this talk. Edge AI is coming in big time. We are also dealing with integrated frequency bands now, integrated IFB technologies. We are dealing with integrated terrestrial, airborne, and satellite networks, where a network can be in a network we could have satellite-based communication components as well, whereas the terrestrial components also. Energy harvesting and the transfer of energy, wireless power transfer, and those technologies are also evolving parallel with the advent of 6G. And already, although 6G is to be deployed by 2030, already we have started talking about beyond 6G. Actually, that is the key crux or the key challenge that the researchers will face over these years to make sure that their research stands validated and their research stands relevant to the current technology or the modern world. This basically happens because the different countries across the globe, suppose maybe China or the different countries, Southeast Asian countries, and also the Western world have taken up 5G across the different like pillars. Like somebody has adopted it in terms of the antenna design, that is basically the MIMO based, the ultra MIMO based setups or the massive MIMO setups, whereas some of us have taken it up in terms of the frequency band. So the technology is now evolving at a manifestation scale or a large scale across different dimensions. That has led to this. Madam, next slide. So what are the improvements of 6G security architecture? So as we know, this is a basic structure wherein we can consider like how the security protocols would flow, which I have numbered here across numbered here across the different components of the network. So you can see right from the user equipment to the SDN and leading to the home network. We can also see the embedded SIM or the SIM module which is placed in between. What would happen basically is earlier all these components that are there were basically operating at a synchronous or a sequential sort of security pattern, where it would be easy for the intruders to actually to actually attack the system and to get the necessary control that they want to do the harm to the system. But now all this would actually, with the advent of the edge communication or the edge AI, edge-based computing AI, and also the quantum computation aspects coming into the picture, actually what now all these sequence of operations would take place in a parallel method, where they would be processed through many parallel modules. That's how things are moving actually presently, how it would move, and that would lead to a very a large scale level improvement in the security architecture of 6G as compared to the previous generation. Madam, next slide. So these are some of the connectivities using the OWC, that is the optical wireless communications, where we can see that through the cloud, the different communication components or the different communication end users, like a train or an aircraft or the different vehicles, where we can see that ultimately, if we are considering a vehicular networks, as you can see here, the V2X would also connect to the cloud. If we consider the the LED, or the network connectivity related to healthcare, that would also ultimately connect to the cloud. So all the or the Li-Fi or the OCC technologies at our smart homes, that would also ultimately connect to the cloud. All these components, when they would connect to the cloud, basically what it would happen is ultimately it would be the entire processing would be a cloud operated processing. That is, the resource requirement will be very less, and for processing it, we would be needing ultra fast processing paradigms, and including quantum, including edge AI and other related tools. And for that, definitely at the back end, as my second collaborator, Dr. Devi, will be explaining, like the VLSI based advents and AIML's role in improving VLSI designs would play a key role basically in the wireless communication domain. Madam, next slide. So in VLC, a number of attacks are there. So just to give you an insight of what kind of attacks could come off. So there could be spoofers, there could be jamming attacks, there could be even access control attacks, where your like channel could also be I should say hijacked at that particular point of time. There could be attacks in connection with the authentication also. We would think that putting in multiple layers of authentication in our network would be would be good, but the problem is, like, even the attackers are now very intelligent, and they would try to always actually have their own cracking codes or erroneous codes, which they would try to attack your system with in the authentication stage. So we should be careful about that. Also, the eavesdropping attacks and the data modification attacks, as in the previous generations, are also there when we talk about VLC. My point about bringing about VLC or visible light communication here is because the coming era of communications will see the advent of quantum, because in light communications, to have the necessary to exploit light communications to the full extent as far as computation is concerned, in terms of bandwidth, we might be already we might be like dealing with in terms of bandwidth. Light communication will always provide us the best physical resource possible, but to exploit the computations part properly, we would be requiring technologies like quantum. So in that, once the quantum aspects come into the picture, the security and the attacks have to be really looked into. For that, the hardware design or the FPGA and VLSI based design should also adjust themselves accordingly. Ma'am, next slide. should also be dealt with accordingly. Yeah. So IoT and cellular networks. So when we talk about the chip-based designs and the real hardware-based connectivity designs in IoT and cellular networks. So earlier IoT networks were considered to be mostly applied to the ad hoc networks, or like mostly applied to the sensor node networks basically. But now IoT has grown, and with because of its compatibility, its versatility, the efficiency, it has grown. And now what has happened is basically like IoT has now become an integrated part of the cellular network, and IoT based, like most of the applications which are satellite borne, or most of the applications which are having some remote component associated with them, those are mostly considered to be focused around the IoT based approaches actually. So that is how like it is necessary, and these are specialized networks which should be integrated to the main cellular network, as the purpose of 6G is to integrate, or it is to integrate the different network components at one place basically. So that is how IoT would play a big role, and also the IoT chip size and the IoT chip layout structures will also need to be getting improved as higher millions. So I should not say higher number of devices now. I should say higher millions of devices get connected to the network basically. Next slide, madam. So another important aspect that has come into the picture is the advent of quantum, the light communications through packets, where each packet is considered to be an independent commodity of a certain energy level. And the main purpose of using quantum communications in our cellular or wireless networks is basically to modify, not to really replace, but to modify the transceiver structures and the repeater structures, and also the interface, that is the channels, the RF based wireless channels, with your quantum based designs. And when we talk about quantum based designs, the entire hardware now has to be built on from scratch, or from the perspective of quantum, and the VLSI designs or the architectural designs will have to now also adapt accordingly to suit the technology requirements, or rather I should say the conceptual requirements which are connected to quantum. So three applications are for the secure communications, for the quantum repeaters so that the energy can be preserved very well, and also the quantum interface. So these are three applications where quantum communication has to be looked into, both at the like the designing level, or I must say in today's age the software level, and the hardware or the VLSI based approach. That is where quantum communication will come into the picture. Madam, next slide. So AIML in next gen wireless communication. So this actually brings me to where actually in next generation communication networks AIML would be used. So if I say that, then in since all our aspects related to communications of the previous two generations, that is our later 4G and 5G, have been based on software defined approaches. So AIML being a software paradigm, or a revolutionary software paradigm, I must say. So in all aspects connected to optimization of the network, connected to the maintenance or predictive maintenance, connected to spectrum, how you are allocating the spectrum, how you are managing the spectrum, how you are allocating resources, channels or sub channels to the different users, how you are explore, how you are maintaining the security, the energy efficiency, the network planning, slicing, and also the quality of service aspects, that is the performance design of the receivers. In all these aspects, AIML based approaches will play a big role. But my key aspect in connection with today's talk is to mention to you that AIML based, along with all the other communication oriented aspects, communication design aspects, or the communication technology related aspects, the implementation aspects of communication would also be there, where the FPGA systems and the chip design will now, instead of being conventional, will be AIML or intelligent chip design would come into the picture for the next generation wireless communications. That is, the AIML will be incorporated into VLSI, or AIML will be incorporated to the chip design dimensions, so that the parallel hardware structures can also be formed, which would suit the softwares or the algorithms that will be developed for the communications technology basically. Madam, next slide. So this is basically an architecture of AI/ML intelligent 6G networks, where you can see this is basically a very common photograph from your in all the relevant textbooks related to next gen communications or 5G and 6G communications. You would see that where all the different AI enabled functions have been or applications have been highlighted, and you can see there are around 4 layers highlighted if you see towards the left of the screen. So the smart application, so it starts with the intelligent sensing layer, where at the physical layer level sensing and acquisition, we are applying the AI/ML based approaches. And it goes up to the data mining, where the data analytics part is also now AI enabled. And next it goes to the control or the sequencing operations, where we are talking about task scheduling, resource management, parameter optimization. So all these are under the intelligent control section, and also the smart applications layer, where the automated device, the services, basically the services are also AI enabled. Basically the service layer is also AI enabled. So this is how the structure of the AI enabled 6G network would be, or the 6G application paradigm would be. Yes, madam, next slide. So these are some of the AI threat scope and the security issues. So if I consider the security challenges, then since huge amount of devices are there, so a lot of things will come into the picture in terms of the visibility, how much of data is accessible at the how much of data is accessible at the different nodes. Then trust factor is another important aspect. We are having the ethical and legal issues, where we're already talking about AIML, ethical AIML basically, and the extensibility or the visibility or scaling up of the scaling up of your activities, also controlled security tasks and adaptability of the models, basically. So these are some of the things that we need to look into. These are some of the challenges and the different attacks I have already discussed here. More extensive attack or examples of attacks are given, where we are having poisoning attacks, evasion attacks, then model inversion attacks, AI middleware layer attacks. So a lot of different types of attacks will also come into the picture when the 6G networks are fully deployed. And that too, some of these aspects will be target portion of the network, but also will target the strong. Madam, next slide. My next slide. So we are also having a concept of the edge computing, where the edge computing is now, as I have mentioned, that we are talking about with the advent of so much number of devices and huge number of devices at any nodal point. We are now talking about all the cellular network processing, data processing being at the edge level, on the edge, or basically with the in a decentralized manner rather than being on a centralized manner. And edge AI and ML algorithms will play a big role. So all the potential applications of edge computing in terms of speed reduction, in terms of the delay reduction, efficiency improvement, distributed processing, those things are obviously there. But along with that, key phase is for all these type of computational aspects, we need to have an intelligent physical layer at the basic level, or at the ground level. We need to have an intelligent physical layer, wherein the AI/ML enabled hardware systems and chip design will play a key role for the on-edge processing. Otherwise, without having that in place, an efficient edge processing will never be possible. Next slide, ma'am. We are also talking about sustainable cellular networks, where we are not only talking about having very high speeds of processing, but and also very low processing delays, but we are talking about sustainable cellular networks in terms of energy efficiency, in terms of the in terms of having low power technologies which have evolved over the years, like LoRa and those type of other techniques. And this type of techniques are coming in. We are having NOMA as a multiple access technique, and this type of things are there. Also, we are having basic level battery optimization techniques also in terms of the state of charge. Those are new technologies that are taking over in the electrical engineering domain, and also converted to low power electronics as well. But we need to have a very adaptive, intelligent and robust FPGA design, and also chips. The chip design should be such that the low power requirements are so that the low power requirements, which are the need of the hour, they would be supported by the AIML assisted wireless system design. So these wireless AIML assisted system design components are basically will be the key facilitators of the future. Basically, next slide, ma'am. So these are some of the AI, the 6G applications in the different domains, and you can see whether you talk about autonomous vehicles, whether you talk about the extended reality or the holographic communication, where a friend of yours can directly virtually be present at your place from a huge amount of distance. If he is from US, and he can be virtually with you for celebrating your birthday. And also technologies like BCI, digital twins, smart grid 2.0, for all these type of applications, it is very necessary that the hardware improves. Without the VLSI based approaches, it's very difficult. Next slide, ma'am. So with this, my part is almost over, where I've touched upon the next generation wireless communications and how VLSI based analysis and processing is actually VLSI based approaches are coming in or necessary in the next gen wireless communication technologies. These are some of the references for my part. Madam, next slide. So this is my part. Thank you. So I hand it over now to Dr. Swagata Devi ma'am to carry forward the presentation. Madam, please.
A very good evening to all the participants from any other countries, and to especially a very great thank you to all the organizations of all the organizers of the conference. And I feel privileged to be a part of this tutorial today. So already we have been, I think, Sabyasachi sir has just now given us a very beautiful presentation on what our wireless communication technology is going to be coming up in the next few years. So suddenly when sir was going on with the tutorial, I realized one thing, that today's tutorial itself is a very beautiful example for our topic, that is AIML driven VLSI system design for next generation wireless communication technologies, where obviously AIML is the software, the VLSI design gives us the hardware, and the wireless communication is the reason that we are capable of interacting with one another. While I am sitting at one part of India, and the organizers at Sri Lanka, and the participants are from all over the world. So this is the beauty of electronics actually. So my topic is a little bit deviated from basic wireless communication and talking about how integration of the VLSI system design is in the wireless communication. Nowadays, every field that we have in our countries is quite multidisciplinary, because everything is dependent on one another. So coming to the foundation of the VLSI, Murray had told us that in every 2 years, the number of chips in a circuit would be doubling. Like the number of transistors in every 2 years, it will get doubled. And that started in the 1970s, and that continued up till now. It has been continuing. And due to this law, what is happening is that the number of transistors that are capable of being accommodated in a chip are getting increased year by year. And we started from, I think, 540 nanometer technology, and we are now talking about 2 nanometer technology. We are even talking beyond 2 nanometer technology. So this is how much we have come across. Now, we, the scientists or researchers, are thinking beyond 2 nanometer technology. Now, what to do beyond it? Because now, while doing the scaling, mainly we did constant field scaling, voltage scaling, and gen relay scaling, like both, doing simultaneously both. so that without disturbing the all parameters, the number of transistors could be doubled in the chips. And for that reason, if you observe that the devices which we used maybe in our early 90s, that is the computers that we talked about, it used to take up a whole room. The heat generation, the heat dissipated from those computers were large, cooling fans were required. So a large amount of space and resources had to be invested. While we are at an, we came into an era where there were now laptops that we could carry very easily, and now our phones are so sophisticated that it can do any work that a laptop could process. That is how our processing speeds are getting increased. And beyond, as I said, beyond 2 nanometer now scientists have to talk about, because of the leakage problem, or there are different issues which are coming up. There is, beyond the scaling, the thermal issues are there, then there is quantum tunneling. So uh, instead of the smarter integration, now we have to think about now smarter integration right now, rather than only decreasing the sizes of the transistor. Now we need to think more, like more new technology. Can we shift from the FinFET or the tunnel FETs to now next to the gate, all around field effect transistors? All this kind of researches are going on. So basically, the applications of VLSIs are quite huge. In fact, every day, whatever we see around us consists of VLSI. We talk about the processors, the memory devices, consumer electronics, which have a very high market everywhere. Then even our cars are smart nowadays. So all the things that we could do through our phones, most of the things are nowadays possible in our cars also. We couldn't imagine previously, maybe in our 90s, that while driving we can watch a movie, which is again harmful also. So that couldn't have been done, but now it is now it is an era where we are capable of doing that. So in this slide, if you can observe, there is the communication system. Obviously, VLSI plays a very important role in this part. And this is today our topic of discussion in our tutorial itself also. So mainly for dealing with the ultra fast technologies, or the thing that when nowadays, even there was a recent news that in, I think, Japan or China, some kind of technology has come up for which immediately the entire amount of data that has been uploaded in Netflix can be downloaded in seconds. So that is how fast things are getting, and how fast we are urging for, like faster things more, or we are so desperate of the need of speed, that we are not thinking daily about how there is brilliant minds behind these all things, where people are integrating this VLSI and wireless communications and AIML. Even in our medical electronics also, I think that I need to mention, because nowadays surgeries are being performed by the robots, and has been possible only because of the integration of the multidisciplinary things. So one of the research prospects of our electronics is 5G and beyond. And today we are going to talk about how this 5G how the VLSI has affected the 5G, or how are they going to be interdependent on one another in the coming years. So evolution of VLSI, if I talk about now, if I talk about the 1G, we used to have phones where there was, we had to, just we were capable of doing calls, nothing else. Or maybe even if we had been playing games, maybe very, very minimal or very basic games were being played. But nowadays we are at a position where we can do everything with the help of our phones. We are capable of sending large amount of files. We are capable of sending large amount of data to any part of the world within seconds. And previously, while loading a image, also it took us hours, to download an image from one part of the world to the other part of the world. It used to take hours, but now it's a millisecond, microsecond kind of thing that it gets downloaded. If you have good speed or good internet bandwidth, you get it immediately. So this rising demand for the speed also is dependent on the VLSI circuits, which are providing the hardware for the same. So basically, there are the RF designs, or the analog and digital modules, which are present in these circuits, are most important, because as analog designers or as digital designers, one of the things we have to keep in mind are the latency, then power consumption, then area, the performance parameters. These all things we have to consider while designing, so that there can be transmission of signals seamlessly without any interruption. So even Previously, we used to have systems where separately the RF part would be separately in a different chip. Nowadays, everything is, as we say, system on chip, SoCs. Everything is possible in one complete integrated chip, which might be in the size of the tip of the finger. We are doing brain surgeries where your circuits are being placed inside your brain, which are controlling your brain. A person who is going through epilepsy, a person who is going through Alzheimer, his brain signals can be controlled by the beauty of the electronics, by the beauty of inserting a chip inside the brain. And these kind of things are also possible, or you are capable of controlling those signals which through the circuit which is placed inside your brain, but with the help of the technology that is your Wi-Fi. So ultimately, your wireless communication plays a very important role when we talk about VLSI, because the transmission of the signals that we are doing from the outside world to the internal part of the body, those things also are the Wi-Fi module only. So ultimately, these all things are related to one another. So if I, as I said, when I talk about evolution, we started from the 1G in the 1980s, and today we are talking about a 6G, which is the next era where AI methods are integrated, and we are trying to build up something, as Sir has already mentioned, holographic communications would be possible. So then again, different, all the fields, something which we imagine maybe in sitting in 1980s, or we used to think like this, maybe if it is possible, then only God can do it. But now humankind are possible. Humankind, human mind is possible of dealing with all these kind of things. So that is only no other reason. That is only because of all the things that are going on, all the designers, all the researchers who are working on. And if you see the design hierarchy of the fundamentals of the VLSI system design, we can see that we mainly depend upon the three parameters, that is your power, performance, and the area. As we talk about speed, with the need of the speed, there is high rise of the power consumption. So we should be also looking upon the methods through which the cooling of the circuits should be there, or even if like as we talked about medical biomedical things, if I'm placing a Wi-Fi module inside my body also, then there will be high heat generation. So that needs to be again settled down. Otherwise, what the tissues in the brain and all those things can be damaged. So for that reason, also the there should be importance given to the power consumption hugely. Whether I talk about VLSI, I talk about wireless communication, it is the similar concern as designers for us. Whenever we are designing a circuit, the main thing is that first we have to decide which kind of device, whether TFET or, as I mentioned, GFET or FinFET, which we are going to use, and what kind of circuits we are going to use, what kind of system is going to be designed, or different architectures are there. If anyone is from analog, you would know whether we are going to use folded architecture, whether we are going to use telescopic architecture, whether we are going to use differential amplifier. Depending upon the different applications of our need, we have to decide what kind of circuit we need, and accordingly we design our devices in that manner. So overall, the VLSI can be divided into three parts. One is your digital, second is your analog, and third is a mixed design, where it is a combination of both digital and analog. So this interface between the digital and the analog world is taken care of by the VLSI part, but the further processing of the signals, that always needs your wireless communication. Or nowadays, as the AIML techniques have done, what AIML techniques have basically reduced the mundane methods that we used to do, the monotony of the methods, or the human error, which wherever it was possible, that these things are being removed by AIML methods. Moreover, also the speed, which, as I said, because of human error, because of monotony, this method used to take a lot many time. Now, because of the presence of these AIML methods, this mundanity of the life has reduced, and as new techniques have come out, and through which same things could be done in very small amount of time. There are key challenges for in CMOS which we face. One is our power, definitely. Then there are leakage current because of the interconnected connects. There is a problem in the latency, and you know, if there is latency, then of course the seamless transfer of the data or the signals might have a delay. So next, when we these are some VLSI architectures for wireless communication. So as VLSI designers, if we want to work in wireless, what kind of help can we aid to the wireless designers? So in modulation and demodulation of the signals, which is the baseband processing unit. So that acts as the brain of the chip. And again, there is the RF front end where there is receiving and there is transmitting of the signals. So all those RF designs need low noise amplifiers. There are power amplifiers. There are analog to digital converters, digital to analog converters. All these designs, which kind of design would be appropriate for what kind of application? These are the things which an analog designer or a VLSI designer would be doing. Similarly, the modulator, demodulator, all are made up of ultimately the basic circuits. So if each of this module, each of the circuit consumes a lot of power, consumes a lot of space, then the entire design of compact systems in this world goes in vain. So as analog designers, it is very important that whatever the need of the hour for the wireless communication is, we go hand in hand with those aspects and we keep in mind the main problems or the main issues of the designs, and then we decide and design with the specifications properly so as for seamless transfer. There is again multiple antennas are taken care are installed in different channels, and as many number of antennas are increased, similarly the amount of power consumption also gets increased. So if we go for some low power circuits, and different techniques can be used which can bring down the power, like resource allocation, resource sharing, or for some kind of time sharing. So this kind of if methods can be implemented, then definitely those circuits will consume less amount of power, and which is one of the reason that the VLSI part plays a very important role. Then, as I said, the low power and high speed. High speed is another thing. Now, if I am given a circuitry which can do everything, but the speed is very low, I don't think so that serves the need of the hour. So I have to have a system which can do everything. Along with that, it can provide me the high speed, and where that is where we are going beyond the 5G. Now we need things to be done in microseconds. We are already capable of doing, but we can do a lot more in case of the 6G technologies. So basically, all the circuits that could be provided by the VLSI engineers for the 6G technologies, this is what your VLSI in Wi-Fi is about. Wireless signals are about. So ultimately, from silicon to the wireless chips, this is the main design flow of our VLSI system. As I said, we need to understand what is the requirement of the Wi-Fi systems. So we need to understand the specification, only then the RTL design could be done. And then finally, once the entire simulations are done, entire tape out is done, we can do the verification whether the design rules are satisfied or not. Once everything is done, then we can synthesize it or we can fabricate it. As you all know that the fabrication of one single chip takes a lot of, it costs a lot of money. So we have to be very assured while going for the synthesis, while going for the marketing, or while going for the publishing of all those chips. So we need to be very clear about all these things. So if I talk about a design flow, the design flow is that only that first we go for the specification, then we go for the RTL design. After that, we go for the verification whether all the design rules are being satisfied or not. All, if there is a leakage, if there is a delay, all these things we check. And finally, the final product is done from synthesis. And once it comes back, we check whether the simulated results are equivalent to the practical results or not. If it is fine, then definitely those circuits can go for production. So different tools which we use for designs are the Cadence is there, Synopsys is there, Mentor Graphics is there. These all things, there are different technologies. As we because of the fabrication facility, there is still lack in fabrication facilities, for which the design engineers are still working at 180 nanometer technology, whereas the Asian countries which are very advanced in technology, they are working in 5 nanometer technology. So we are somewhere in resources, we are lagging behind, where our governments are trying to do, they are investing a lot in those things. So currently, if you have been following the news, you could see that the next job yielding opportunity is nothing but your semiconductors after your AIMLs. So the key building blocks, as I said, for the wireless communication are first are the digital blocks, that is which comprises of the modulators and encoders, signal processors. Then again, for the analog blocks, which are again implemented basically in RF designs. There are low noise amplifiers, mixers, then phase lock loops, PLLs. So this each every module, the design of each and every module is itself a very huge research topics. So whether power management units, then cache and memory buffer system, these all are at the VLSI parts which can be worked on for researchers. And as I said about the low power and high performance, the main one of the ways to, as I said, allocating the resources for different time. In that way, if dynamic allocation is done, we can share the resources, and that way the power can be reduced. Or whenever the circuit is not being used, if we switch the gating to another circuit, that way also certain power can be reduced. Adaptive biasing, where the circuit senses when it should go switch off and when it should turn back on for the current saving and for power saving. And of course, going for the technologies which are which can give us mainly low power technologies, from FinFET, from TFET to some different kind of technologies which can be upcoming, like as I said, GA, FATs. These all things can be emerged together with the circuit, so that there can be a solution to the low power issues. If we can control the sub-threshold issues, then of course making a circuit work in a sub-threshold region can be one of the way to save the power in the circuits. So if I talk about AMI in VLSI, whenever we talk about the analog designs, the main issue is that it depends on the expertise of the circuit designer, whether a circuit can be worked in one day or it can take months for a circuit to run properly. It is completely dependent on how much expertise you have over that particular software. But the same thing can be replaced actually by the AIML techniques. There can be some automated methods through which we can find out the parameters, and we can decide if we have a data set, we have the proper ANNs that we need, or proper machine learning methods. Then through optimization, we can pre-decide the W by L ratios, we can pre-decide the biasing currents, and in that manner, we can design a circuit for minimum reduction. So this is just a glimpse about how AIML can be used in case of training the data sets, and how the same programs which we use through Cadence and AIML methods can be a helping aid to the Cadence and the Synopsys, where we go for a design, we manually enter the things. Instead of doing that, if we have a program where we give the design rules, and immediately according to our application, the exact WL ratios can be calculated, the exact current, the exact voltage can be calculated, through which the power can be minimum, the area can be minimum. That is one of the way how your AIML can make a difference in case of VLSI. And even if you see this diagram, we say this is the analog design octagon, where every parameter is dependent on one another. Now, if I'm talking about the power, if I'm only concentrating on the reduction of the power, what will happen is that my noise will get affected, or my linearity might be deviated, or my gain might increase, but at the same time, my input or output impedance might deviate from whatever the actual values should be there. So ultimately, all the parameters are correlated. So in analog design, we cannot think of something where only one parameter can lessen while without affecting the others. So these AIML methods can help the designers in that manner also, through which thinking of multiple parameters like power, space, time, speed, all these things, if we think together, we can minimize our circuit in a better way. So just a comparison had been done using the AIML methods and the traditional methods, and it had been found that the AIML methods can give us far better results in case of our circuit designs rather than our traditional methods that we have. So these are the design challenges and the future direction in which, using our cadence and using our different methods, we can go for the solution of the problems that we have. Design complexity and verification. Then there is design of the RF and the digital photonics, and in a single chip, everything on a single chip. That will again challenge the space complexity of a circuit. Then using the AIML and the different quantum computing techniques, which are the next generation things which are coming up in wireless communication as well as in VLSI system. These all can be these can be the aspects in which we can work in, thinking that we have a platform where we want to integrate both these disciplines. So these are my references that I had used. So ultimately, the in my conclusion, I would like to say that ultimately there is a lot of scope where VLSI and wireless communication can work together along with AML, and we need to understand what is our need of the hour, and we need to accordingly plan how the power or space or time and speed can be reduced as VLSI designers so that it can help in a seamless transfer of data and files using your wireless communication. Or we are now talking about holographic transmissions and all those things. So it is way behind only data and files, I think. So with this, I would like to conclude my part, and I'll hand over to Shweta ma'am for the next continuation of our tutorial.
One and all, hope I am audible enough. I would like to thank the organizers, my fellow collaborators and speakers who have given this chance to present one of the promising feature of upcoming 5G or beyond 5G applications in wireless communication. Ma'am, would you please change to the next slide, please? Yes, so the topic what I have chosen is considered as an intelligent reflecting surfaces for next generation wireless communication technologies. Next slide, please. The reality at present is that we are talking about 5G and 5G beyond, but still with respect to the 5G deployment, still we are facing the coverage issues. We are not having that level of connectivity, right, at certain areas where it is highly congested with respect to the urban area or some closed environment where the signals are not reaching to the users. As we are moving towards 5G and beyond generations, we are talking about heterogeneous connectivity from minute picocell to the larger area to be covered, whether it is a closed room or visible light communication and all. So, certain very promising problems which are yet to be handled, like coverage or availability of the signal, for that one of the option is intelligent reflecting surfaces. Next, click this. Yeah. So what are the challenges with this existing technology? If I talk about, basically we are now uh, running behind the ultra high data rates because the high end application, HD application, short duration, short delay we can talk about, right? With energy efficiency because we are looking for the global perspective as well. Global coverage and connectivity is the major thing where we are still lacking to have the secure and the faster connectivity reaching to all corner of the world, and also extremely high reliability and the low latency, which are the major features which are to be retained for the upcoming next generation wireless systems, technologies, or standards, whatever we talk about. So here we can observe that current technology trends are still inadequate for meeting all these basic demands. Up till 5G or we can say 4.5G, we could able to achieve the quality of voice, data, and connectivity, multiple application in terms of internet of connectivity. But still, we are lagging behind the faster response, higher data rate, and still we are demanding and trying to reduce that latency by any means with the proper coverage and the security. Next slide. So the traditional approach, what we are seeing today that we have like millimeter wave transmissions, we have ample number of network hardware installed. We are talking about terahertz beam training. We are talking about satellite-based communication. We want all aspects to be covered in terms of like computing, power, time, latency. We are increased with hardware like anything. If we see around us, we are with too many wires and hardwares which are deployed, which are nothing but the increasing the cost as well as complexity, because maintenance is another part as a, or we can say the byproduct when we go with higher level of installations or the network deployments, right? With respect to you that higher frequency utilization is another target with the or the higher generation of wireless communication network, like we are talking about millimeter wave or the terahertz band. As we know that these particular ranges travel with less distance or a smaller distance, so the coverage would be another challenge, right? Also, with the higher frequency, the interference is another target. If you are having too many base stations or access points deployed, we do feel that there are severe interference issues are also to be solved parallelly, right? So, due to this greater densify network, how to handle the unavailability or the signal reception at every corner is another task which is to be adopted or which is to be looked upon, which can basically give the user satisfaction of using the higher applications or the standards in terms of wireless communication. Next slide. So, the integration of intelligent reflecting surface is imperative to address this existing limitation, which is cost effective for 5G and beyond. Now, what is basically, as a rough idea, if I say that intelligent reflecting surface is something which is diverting the radio frequency signal to the required direction. It is as good as we are directing light. Suppose we are talking about visible light communication, as Dr. Patel has very well explained. And visible light communication is something which is inside a particular area where you have a constant light connectivity. Now, in between, if something as an obstacle comes into it, your visible light communication won't be possible to continue with the same efficiency. Now, in that situation, if we have certain kind of solution like intelligent reflecting surfaces, which are basically diverting and trying to send signal or giving radio frequency signal to direct to the particular angle or to the area or to the corner, will satisfy the objective, means continuing with the visible light communication with the higher data rate with coverage in all direction. Right? Next, please. Next. Yeah. So now we are basically having this concept of massive MIMO where thousands of antennas are being placed, which are basically being formed and targeted to the particular user to give the targeted service. Now, what the user is behind certain obstacle, behind certain some surfaces or building where those signals are not able to penetrate it. So, being in the 5G with the massive MIMO, we are not receiving those quality of signal. So, the important idea behind intelligent reflecting surface is that how to resolve it. So if the lower figure, if you see, there you have two links which are shown. One is with the sky blue color is MIMO link, and another is the green line which is IRS link. So the problem with the MIMO link, it is shown that the availability of signal behind the larger buildings or some construction or some obstacles. But in that situation, if we are placing some IRS in such a way that which are basically giving the different path, different direction to the required signals, which are reaching to the user without any major processing, which is the beauty of intelligent reflecting surfaces. So in such situation, with having the IRS, we are able to give or we are able to reduce the we are able to reduce the place of placing the hardware, and we are still able to receive the quality of signal. Next slide, please. Thank you. So basically, this picture gives you a glimpse of how IRS basically look like. So if you see, there is some colorful square boxes you are able to see as heterogeneous surface, which is used for intelligent reflecting surface. This different color basically indicates different impedance, which helps to direct particular signal to divert in particular angle. If you are remember slit experiment where if you are changing the slit with the light transmission, the light can be directed to the left, right, or any direction what we talk about. Similar concepts have been applied for intelligent reflecting surface by incorporating some components in such a way that they are able to, as and when required, just to direct the radio frequency signal into the particular direction. So this controller is connected with all the component behind intelligent reflecting surface, and it gets is required to divert the signal to the particular user direction. If you saw the below part here, we are using beamforming at the base stations where you have thousands of antenna as massive MIMO concept, which is one of the promising thing in 5G generation, right? So this beam forming is basically giving you multiple beams in the multiple direction. Now, if these beams are basically strike on the intelligent reflecting surface, you can see that they are getting directed to the different users, right, with respect to the direct path, right? So this basically solves the issue of availability of signal reception with the least interference as well as with the best quality. Next, please. So similarly, yeah, okay. So yeah, ma'am, previous like this, previous, just a click was, yeah. So if you see with the topmost right figure, the color pattern have changed. So that basically gives you the idea that the impedance have been changed because it is to be directed to the user 2 compared to the previous case where user 1 was the targeted user to receive the signal. Like this. Okay. So if I say that your operation in a nutshell, that particular IRS comprises of every individual element. These square boxes are comprises of some passive patch with a switch which is controlled by a programmable controller. This means here we need to control what? We have to do some tuning of impedances which basically helps to direct the signal. That has the tuning length of delay lines, that how they are getting controlled, and the phase shifters, right? One click please. Okay, so this individual RLCs are, if you see, they are nothing but the composition of RLC circuit. These RLC circuit are need to be either switched on or switched off. How they are getting acting as a direction elements which direct incident signal to the particular direction. One click, please. So these are such RIS components, you can say, or the elements, lumped elements, which are connected systematically to make it on and off situation. Click this. So basically, if you see, it is divided in three sections. One is the passive operation. See, IRS are basically passive component which are not doing any amplification, error correction, nothing like that. It is just receiving the signal and just giving a direction that in which direction it has to route, right? So that is the beauty of IRS, which is very, very promising in upcoming next generation wireless application. So IRS is this passiveness feature basically helps to avoid extra processing what we normally expect delay kind of situation, right? Somewhere we need to receive the signal, need to amplify or need to filter and then again resend it on the other frequency likewise. But this processing is not the part of IRS. So they basically reflect and modify the existing signal transmitted by the source. Now, modify in a sense that its direction. This passive nature makes this IRS technology energy efficient and cost effective compared to any active relay technologies we use. For an example, you are having a Wi-Fi router in a very big hall which is not covering your signal to all corners of the room or that particular hall or a house. In that situation, you are going to put some amplifier, some repeater or some booster which basically gives you the boosting of the signal. So this booster, what it is an active device. So it requires extra hardware placement, power, and so many things, right? So, and also the processing and the delay, which is going to be added because of this processing, what is required in active system. But the simplicity of IRS, which is with the low power consumption, makes it more appealing for the large scale deployment. Next. There is a, yeah, the phase shift control. The IRS achieves this signal manipulation by adjusting the phase shift of each reflecting element. As I explained, that these colorful boxes are just to give you an imaginary idea that as you change this color pattern, the particular element impedance gets changed. Once the impedance gets changed, the reflectivity of that particular element gets changed and accordingly your signal is getting diverted to the different direction, right? Now, Each element can introduce a phase shift to the incident signal, allowing for the constructive or destructive interference of reflected rays, which is part of wireless, so you cannot avoid. But this phase control enables the formation of directional beams, enhancing your signal strength in the desired direction and suppressing the interference. So, as it is, it's like the battery, or you can say the torch in your hand, where you are able to direct the light into the particular direction where there is a darkness, you are able to see the signal. So the other side may not have that impact, but you are targeted to the particular direction to receive the signal, right? So this is what the concept behind this. Next click, please. Okay. Once after that phase shifter, we need to have this amplitude control system as well. While phase control is the primary mechanism for IRS operation, some of the IRS also offer amplitude control. I'm not saying that the IRSs are only passive, they can be active as well, where some processing can be included, but it is depending on the application. But at present, majorly the research is focused on passive based IRS system. This allows for further fine tuning of the reflected signal by adjusting the strength of the reflected wave from each element. Now, this feature is another layer of flexibility, enhancing the system's ability to optimize signal quality and coverage. I would highlight here one thing, that even underwater communication, there also, as we know that there is a limitation of the signal travel in the water medium, there also IRS are playing a very crucial role, and they are very good research is going on in this domain as well. So one who is interested in working in this domain, there are very good opportunities. So one should definitely deep dive into it. Next slide, please. Okay, so if I say what is behind the IRS, so it is nothing but your patch antenna. They are the lump component made up of RLC circuitry. You have to make it either on and off, right, based on this tunable chip and reflecting elements. This control is basically based on some FPGAs. So as madam has already explained that what is the role of VLSI, so the background or the backend can be handled with some intelligent VLSI chip designing, so that the controller can do all these mechanism and controlling each element to be either active or non-active as and when the signal basically strikes on this metallic pitches, right? So the intelligence can also be added, while we can have this IRF controller to communicate with the other surrounding maybe base stations or terminals, so that it can tune the signal very fast and dynamically as and when it is required. So this planar surface comprising numerous passive reflecting elements that can independently induce controllable amplitude and phase changes to the incident signal. So it's like handling this even signal direction by IRS, which is a very strong weapon, we can say, what we can use in future wireless next generation communication systems. Next slide, please. Okay, so if I say about IRS functionality, just visualize this picture which is in front of you, where we can avoiding wires rather than placing these IRS or deploy these IRS on any of the infrastructure which are available around us, like maybe on the buildings, or maybe on the car, or maybe inside the bus, maybe on the hoardings, right? Which are nothing but smart reflecting surface, which are handling the signal propagation and optimizing it, and they looks even beautiful. So I mean, it's like managing the beauty with the more advanced connectivity and signal availability to the user at any level. Maybe it is a small area, or a very urban, or the very dense urban area. Next slide. Click. Okay, so the key advantages are, it's fine. It addresses the wireless channel fading and interference issues, because we know that as many, if we just keep deploying massive MIMO base stations, it is going to have fading and interference issues as well. We are talking about high terahertz frequency ranges. There, the channel impairments are differently active, and accordingly, that the channel estimation and the suppression things are also to be looked upon, which is nothing but the extra processing and the delay. Even it enhances the communication and the reliability and the capacity if we use IRS as one of the promising feature. Next click. So if I talk about operational mechanism, so having the passive reflecting elements which is operate without the need for any transmit radio frequency change. So the point here is, as I said, we are not having any extra bulky hardware which requires to receive the signal, detect it, clean it, amplify it, and retransmit it, which is the normal process we all are aware with. So it is just a directional one, and that is the best part, that it can have only signal reflection and refraction feature to be added or to be used intelligently to have the better capacity or better coverage in communication system. We know that the multipath is one of the promising thing. We can say it has its advantage and disadvantage. So kind of that, where we talk about, of course, reflection and diffraction and all part. Similarly here, the signal reflection and the refraction both are playing a very crucial role in developing this IRS based system. Next slide. So practical advantages of IRS, if I talk about, click. Cost effectiveness, because they are kind of a printed dipole element. So it's like normally a patch antenna that we know, which are there in our mobiles and maybe the major, major equipments nowadays. So this patch antenna, the size, the weight, the cost, everything is so much effective, cost effective, I can say, and which is very much lower in hardware to provide such energy efficient solution, right? So that is one of the key feature or key advantage of IRS as in cost effectiveness. Second, click. Then the operational efficiency. So we know that what amount of power loss, power requirement, or link budget calculation and amplification and noise separation and so many things we need to look while we are talking about actually active communication transmitter to receiver system, right? So here this is the advantage. Another advantage added to the IRS is operational efficiency, where it works in full duplex mode, avoiding antenna noise amplification and self-interference. Also, it ensures the competitive advantage over traditional relays, which is very much visible. Next click. Deployment flexibility. As I say, it is very low profile, lightweight, and conformal geometry, so it can be mounted anywhere. Like inside your room, you can place it as a picture. Inside a bus, you can place it as a wallpaper, or on a building, you can have some hoardings which can act as IRS, right? So in a way, the deployment is so easy. The geometry you can design, of course, right now it is of course in rectangle or square manner, but it can be research, it can be come up with a very good or innovative solution in that direction too. So the placement is the major problem which basically handled by IRS. And if we know that installation of a base station requires permissions and so many things, like on the building or somewhere. I mean, it's a cost promising solution. So of course, one should go with IRS as one of the major likely techniques to be used in the future communication era. Next slide. Also the step also the next slide, please. Strategic importance, that it definitely plays a pivotal element for enhancing the next generation communication system, contributing to the improve the user experience and network performance. See, today we all are talking about 5G beyond or 6G generation, maybe seventh generation, right? So the user satisfaction is something which is highly required and which is at the priority, because we are done with having connectivity. We are having too many sensors around us. We are connected with the 1 Gbps of data rate. So now it's not so much of scarcity in that sense, but what is the user feeling is that availability of signal coverage and the reliability on the network. So that is the very promising and very you can say a key point problem or challenge which is to be addressed in the upcoming generations. Next slide. So just see the picture. The left side shows you highlights the massive MIMO system versus IRS aided small moderate MIMO system. So The coverage in both the pictures are same, but deployment of massive MIMO compared to the normal MIMO system with IRS combination is also going to serve the same purpose. So installation of massive MIMO, designing a massive MIMO, maintaining a massive MIMO infrastructure is very complex, costly, and of course time consuming. Compared to that, IRS are one of the promising solution. Next click. If you talk about the heterogeneous wireless network versus IRS edit, so you can see, you can compare both the pictures. So there we have hardware deployment where somewhere these IRS can avoid that big physical infrastructure deployment as well, maintenance of that as well, and still providing you the proper network connectivity at any corner, whatever you talk about, whether it is a micro base station or macro base station or femtocell or a pico cell, whatever. Next slide, please. So if I talk about the major IRS deployment scenarios, click. Very much important is the indoor coverage. We are able to connect, we are in network while we are outdoors, right? Where we are on vehicle with higher speed. So that is absolutely fine. In the super fast train also you are able to be in the proper connectivity compared to the previous era, maybe in the era of third generation or 4.5 generation. Today we are able to have a very good connectivity while we are outdoor, but still we are suffering with the connectivity issues in the indoor coverage. So in such scenario, if IRS are being installed in indoor coverage, of course it is going to solve that particular challenge. Next click. Another is the industry automation. If we are talking about IoT system in all sort of, one of the application, just to give you a glimpse, there are too many applications where you can deploy these INS, but another is the industrial setting where we are having automated system plant. So there also coverage is another thing, because you have huge machines, huge automatic machines are going on. So their communication, in between communication, can also be handled by IRS. So it is a kind of indoor application itself, but compared to the previous one, which is where the users are there, here the machines also require the proper connectivity to the network. So that's why I have kept this as one of the application to highlight the importance of IRS. Next link. And one of the promising is the, of course, this mobile communication. As I said, that behind a very high rise building, I might sometimes feel that I am not in coverage, and I guess with me, you people must be agreeing to that. That of course that is the challenge. So yes, IRS is another feature can be added with the mobile application also. Next click. So overall, if I just give you a glimpse that whatever we have discussed with this tutorial, talking about the 6G applications and VLSI and all sort of applications, right, which have been introduced by two of the speakers. But overall solution in that, if one of which is very important is IRS, if we keep it, many major other problems can be solved. Like VLSI can be processing can be one of the part. 6G, we are able to have the higher coverage and the better coverage, so that challenge can be reduced. Low latency can be achieved, higher data rate can be achieved, and proper network coverage with reliability is achieved. So if you talk about IRS can be a part of any of the communication like UAV, massive MIMO, non-line of sight, green IoT, millimeter wave, terahertz, energy efficient, cognitive radio, mobile edge computing likewise. Next clip, please. Okay, so this picture basically gives you the illustration of IRS application in future wireless network. Just go through one by one. If you talk about the left side where the satellite is giving you the connectivity or your GPS location or some other network is used there, if you have placed your IRS over there, your localization issue won't be the further challenge. If you talk about the cell edge users, where these users are basically changing their location very fast, in that situation, if the IRS is deployed, the problem gets solved. If you talk about the aerial IRS, where the remote places can also have that coverage, which is another solution people are talking about. The edge computing, the dead zone user, where users are covered with certain area, where the connectivity is not there, under area parking is there, where the connectivity is the issue, IRS can be one of the solution. We are talking about the smart offices, visible light communication. We are talking about the uh, in network while we are moving, while bullet trains and all. there also the IRS can be one of the promising technology to be used in the future generation situations, right? So this is what all about from my end, where IRS can be very promising technology in continuation with the AIML. There are many things which can be added, of course, as AIML to identify the channel and configuring the IRS elements and all. So that can be like extended to any limit. So yeah, there is no limit to that. So of course, people can move on in that direction. So I would end my talk here. And thank you for patience listening. And if you have any doubts or questions, we are here to answer that. I hope. Swijo, I'm giving the mic to Dr. Bhattacharya. Please conclude, sir.
Yeah, thank you, madam. Thank you. Thank you. Yes. Yeah. Madam, can you move to the last slide? Maybe we have a last slide. Yeah. So with this, we are coming to the end of our tutorial talk. So these are the contributor details, all of our affiliations, our contact details, email addresses, everything is available here. Also, I'm very closely connected with the tutorial chair of this esteemed conference, Dr. M.W.P. Madhuranga from University of Sri Jayavardhanapure. So he has our details. So if anyone is interested in any sort of like as any queries related to this presentation, they can obviously ask it now, or also they can contact us offline after this through email, through WhatsApp or telephonic contacts as well. We are most open, and we from India, we are here. We are having institutions, like it's a wide spectrum of institutions actually. This tutorial brings into the picture from India. So we are having two resource persons from the esteemed and National Institutes of Importance, NIT Surat, SVNIT Surat, Dr. Shah ma'am, she already presented, and Dr. Ghanapriya Singh ma'am, who is also a part of the esteemed, dedicated part of this particular tutorial. She's from NIT Kurukshetra. So we have faculties, esteemed faculties from National Institutes of Importance in India. I am representing here the institutions, the state government engineering colleges, and also polytechnic institutions under the government of Assam. And Dr. Devi ma'am, she is also representing here the autonomous universities of the under the regime of the government of Assam, basically under the regime of the government of Assam. So we have a number of collaborators here. We are collaborating for some activities, and if anyone would be interested further in any sort of work related to the domain that we have elaborated today, you are most free to get in touch with us, and we can definitely work upon some meaningful research, and some meaningful collaborations are always welcome. And now with this, we thank all of you for your patient listening, for your patient hearing over the last 1.5 hour, more than 1.5 hour in fact. Thank you so much. So that would be all from our end. Thank you. Thank you so much. I hand it over now to Dr. M.W.P. Madhuranga sir for taking over the proceedings. Sir, please. Thank you.
Thank you very much, Dr. Prashant, and our sincere gratitude to all our esteemed speakers, Dr. Sabyasachi Bhattacharya, Dr. Swagata Devi, Dr. Shweta Ansa, and Dr. Ganapriya Singh, for delivering such an enriching and thought-provoking session. Your insightful presentation have deepened our understanding of how artificial intelligence and machine learning are transforming VLSI system design and next generation wireless communication technologies. We truly appreciate the time, effort, and expertise you have shared with us today as part of ICAIDS 2025. As a token of our sincere gratitude and appreciation for sharing your valuable time and expertise, I am honored to present this token of appreciation to Dr. Sabyasachi Bhattacharya on behalf of the ICAIDS 2025 Organizing Committee. Thank you very much, Dr. Sabyasachi, for your insightful presentation and meaningful contribution to today's tutorial.
Thank you so much. Thank you.
Next, it's my great pleasure to present a token of appreciation to Dr. Swegata for her excellent presentation and for sharing her in-depth knowledge with us this evening. Thank you very much, Dr. Swegata, for your valuable insight and contribution to 2025.
Thank you so much. Thank you. It was a pleasure.
It is now my privilege to present this token of appreciation to Dr. Shweta Ansha in recognition of her informative and engaging session that added immense value to today's tutorial. Thank you very much, Dr. Shweta, for your inspiring presentation and contribution to the success of ICARDS 2025.
Thank you so much. Thank you.
Lastly, we are delighted to present a token of appreciation to Dr. Ganapriya Singh for her excellent presentation and valuable insight shared during this session. Thank you very much, Dr. Ganapriya, for your remarkable contribution to this tutorial and for inspiring all our participants.
On behalf of Dr. Singh, I am expressing my gratitude on her behalf to the conference organizers. She has been an integral part of this tutorial preparation. Thank you so much. Thank you.
Before we conclude, let's